Hello everyone. Today I'm going to share Solana, how it works with you. I believe people right here heard about Solana, right? Yes. Thank you. Okay. A little thing about me. My name is Emerson. I'm a teacher at Turbine right now. And Turbine provides some programs for developers so that people can learn about Solana right here. And if you are more interested in the advanced part, we have advanced program so that you can learn really deep inside the validator. And something I'm going to share today. And also, Solana, how it works is actually a report created by our research program. The student Losting is now working at Helios as a technical writer right now. Okay, what I'm going to cover today is why Solana is so fast. Like people come to Solana is because it's fast and cheap, but probably people don't know why Solana is really fast. And I'll touch into it later on. And as this stage is a hackathon stage, I will talk about the account model on Solana. Okay, if you Google Solana, you will find like this word like proof of history, turbine, sea level. Yeah, but what this words really means? Like it's quite complicated. And thankfully, there's a straightforward way to understand it. We can follow the transaction lifecycle and to see how your transaction happens after it's sent it out and like what things do behind the scene and being included on the blockchain. So you can see that. I break it down into like basically 5 steps. The first, your transaction needs to be sent it out. In Solana, we call it Gulfstream. And later on, the leader validator will build out the block. And this is a block building process. We'll explain it in detail. And proof of history, short of it is POH. It's a clock service. And then after a block being built, we need to broadcast the block within whole Solana protocol. And this mechanism, we call it turbine. And finally, we need to reach the consensus. That means the validators need to verify the block and vote for it to reach the consensus. And that's how the whole process will be like after your transaction is going to send out. Okay, so what's the transaction look like on Solana? Basically, they will have 2 parts. One part is the signature, and the second part is the transaction message. The signature part is that you authorize this transaction. So everyone has your own private key. You need to sign to approve your transaction message. And what's inside this transaction message? We can break it down into little pieces. So the header will include how many signature there will be there, and the accounts write and reads, how many accounts there are write authority and the read authority, and what account you are gonna use inside this transaction. And for the instruction part, is actually the logic you are gonna execute it. So you can imagine that if there's a transfer transaction, the instruction will be transfer. So they will update your balance. So inside this example is a swap transaction. You need to include every account you need to use, including the wallet you're going to sign your transaction, the token you are using. The token mint is actually, we define what the decimal is it and what's the current supply. And the token account is actually the balance of your token. Yeah, so it's quite different from Ethereum. Like Ethereum is, you deployed a contract like ERC20 for a token. But in Solana, if you want to create the token, you just mint a token out. And the token will be minted to your token account. Yeah, so for a swap A to swap B, swap token A to token B, you need to include the mint account and the token account, and also the program you're going to use. Okay, so after we have the transaction, later on we can follow the transaction being propagated to the validator. You can saw the purple path. Inside your dApp, you might sign the swap transaction. the transaction will be forwarded to the RPC node, and later on will go through the validator. And if the validator is not the leader, it will forward the transaction to the leader. And also, there's the connection between the RPC node and the leader directly. But you can see that the quality of service is that if there's more, so you staked it, the quality is much better. So people might be wondering what is the difference between RPC and validator. Anyone here know what's the difference between it? No? No? Okay. So actually, the code base is really it's actually the same. Like they can get the latest status on the Solana blockchain, but the main difference is that the RPC node don't need to stake their SOL. So that means that they cannot vote for the block to reach the consensus. And also, it's not allowed to become a leader to build a new block. So that's the main difference between RPC node and the validator. Okay, so we have mentioned the leader. So what's the leader? People might know about Bitcoin and Ethereum. There's a mempool right there. So the transaction will first go to the mempool and then construct it to a new block. But inside Solana, there's no mempool right there. Instead, we have a leader. Which leader? The leader is actually a validator, but we have a leader schedule. So at a specific of time, we know that who's the leader. The network knows who's the leader, who's the current leader. And the other validator need to forward all their transactions to the leader. And the leader's responsibility is to build the block out. Okay, and also the leader will not always be the same. The validator will rotate it and follow the leader schedule to become the next leader. Okay, so now we have the transaction being forwarded to the leader. What's next? Of course, we need to build out the block. So this is what's happening inside the leader validator. You can saw that there's 4 stages. The first is that the fetching stage. They need the leader validator will need to receive the transaction from other validator. That's the fetching stage does. And later on, they need to verify the signature inside the transaction so that the transaction can be included inside the block. Okay, after the transaction got verified, the leader will go to the banking stage. What is a bank? Actually, the bank inside Solana is the current state of the blockchain. So what does your transaction do is that you want to update the state of the blockchain, right? So let me give you an example. Let's say I have 10 SOL in my account, and Bob has 5 SOL inside his account. If I send out a transfer 5 SOL transaction to Bob, what will happen? Like in the banking stage, the leader needs to update my balance from 10 to 5, and Bob's from 5 to 10, right? So this is how the banking stage works. They need to execute the transaction and update the state, which will after the execution, it will get a new state of the bank. Okay, you might notice that there's an entry. There are a lot of entry right here. This is the secret of how Solana executed really fast. The entry is 64 non-conflicted transaction. If you remember a bit earlier, like right here, we need to define what kind of account we are going to use we are going to update or we are going to use inside this transaction. So every account has been defined. It needs to write or read. And because the user or the developer have defined all this stuff, at the execution time, the validator know what transaction doesn't conflict with each other, so that they can batch the 64 transaction into a non-conflicted order as an entry, so that this 64 transaction can be executed in parallel. Okay, after the update of the state, we got a new bank. But the bank is actually inside the memory instead of in the hard disk. We know that if you want to make the change permanently, you need to write it into the account database. So there will be a phase to be that the bank need to be updated to the account database. We will introduce the proof of history later. And later on, the entry be built out, it will be broadcast out to a turbine tree. Okay. The interesting thing inside Solana is that to avoid the communication overhead, Solana takes continuous block building approach. What does that mean? That means that we don't need to wait until whole block being built, then broadcast the whole block. Instead, we broadcast the entry, like the entry is 64 transaction. Once this been executed, it will directly broadcast out. So you don't need to wait for the whole block being built and then being broadcasted out. Yeah, so this is how the block being built. And later we go on to proof of history. I believe that people have a misconception about the Solana's consensus algorithm. They say that Solana's consensus algorithm is proof of history, but this is totally wrong. Solana's consensus algorithm is proof of stake. The validator need to stake their soul to secure the network. Actually, the proof of history works is a clock service, so that it will function as a clock, so that it will like keep hashing its previous hash. And by doing this, we will know that how many time has been passed between the network. Let's take a look on this diagram. You can saw that every 6.25 milliseconds, there will be a tick, and there will be included 12.5 thousand hash right there. Yeah, I know it's a bit technical right here, but this is the secret sauce of Solana. So that during the hashing process, if there's an entry being created by the leader validator, the entry will be also included inside the proof of history. And this can avoid the other validator produce the block in advance, because the proof of history will change after the entry being included right inside it. And during the current configuration, the block time is set to 400 milliseconds, which means that after you send out your transaction, less than 1 second, your transaction will be included inside the block if it's successfully sent to the leader. Okay. If you are curious about how many validators right there, you can check out the solanabeach.io. You can see who's the current validator, who's the current leader right now, and who will be the next, and their physical location. Yeah, so inside this image, you can saw that there's 1,400 validators, and during the time I get snapshot, and also there are almost 4,000 RPC nodes right there. Okay, once we have the block being built, we need to reach the consensus. And the block is inside the leader's node. They need to broadcast it out to the rest of the validator. How they've been broadcasted? Actually, the entry will be separated into 64 threads. Like it's a small package right there. So it can be efficiently broadcasted out throughout the network. And half of it is data threads, and the rest is recovery threads. Why Solana needs to have this design is that if the threads been broadcasted out, it can somehow be corrupted or missing anyway. So they need to have a tolerance mechanism, so that even they don't receive all the package, they still can be able to recover the whole threads. So if you're a downstream validator, you only need to receive 33 32 threads, you are able to recover the entry. So you can simulate the transaction inside your local storage. Yeah. Also, this tree will be rotated so that every time the leader send out the transaction, send out the package won't be the same one. So that this can avoid if there's a malicious node included inside the network. Okay. Finally, the downstream validator, well, it's quite the same as the leader validator. They need to fetch the threads from the leader. The leader is fetching the transaction, and the other validator is fetching the threads. Later on, they need to verify the leader's signature is been included inside it and is valid. And they are able to transmit the threads to the rest of the validator. Okay, the final stage is the replay stage. It's quite the same as the banking stage inside the leader's validator. They will replay the execution logic inside their local machine and update the state. And then later on, they can store the updated state, or you can say the new bank, to the account database. Yeah. So now, all the validators have the same status right there. And now they need to vote yes or no to the block they are building. If you remember that, there's a leader inside the Solana, which means that at a given time, there will only be one leader is qualified to build the block. So if that leader cannot produce the block within that time, the block will be empty. So it won't happen. The situation is that at the same time, different leader or different validator generate different block, and they need to compete with each other. This situation won't happen inside Solana. Yep. And so the voting is just for voting for is the block right there or it's not right there. If it's not right there, it will be empty. Yeah. So it can continuous adding the block after the longest chain. If you have sent out your transaction on Solana and you check the Explorer, there will be 3 status right there. If the transaction have been included inside the block, it will be processed. And after 2/3 of the validator vote yes, the transaction will be updated to confirmed. And after 31 blocks have been produced, it will finalize. So it will never change again. Okay. I know people right here some of these are builders. So yeah, we need to touch a bit more under the account model. And people want to learn Solana is because they want to launch their own project. Oh no, not mint their mint coin. It's launch their NFT project, right? So let's touch a bit more on the on the account model. When you come to Solana, basically everything on Solana is account. What does that mean? By definition, we can see that there are 4 fields right there. The data field is that you can store any kind of data, but the more data you store right here, you need to pay more rent to store the data. And the second field is executable. It's a Boolean. This means that if it is set to true, that is a program. So the logic can be executed, and on the runtime, it will be read-only. LAMP ports, it's a number. It's 1 SOL equals to 1 billion LAMP ports. It's a unit. Like Bitcoin, 1 Bitcoin equals to 100 million Satoshi. Yeah, it's a unit. And the owner is the program. So every account has an owner, and the owner is a program. And by default, the owner of an account is system account. Is system program. So everyone has your own wallet, and your wallet is actually a point on the elliptic curve. and it's an account. So who's the owner of your wallet? It's system program. Okay, so the owner of your account is system program. And also the executable field will be set to false. And there's no data right there. But if you like transfer some SOL to your account, like you withdraw some SOL to on-chain from SEX to your on-chain address, the LAN port's number will be changed. Yep. So, okay. Based on my experience, this is the quite confusing part of Solana. They have the program right there, but they have like the native program. It's implemented inside the validator, which means that if this program needs to be updated, it needs to require the cluster or all the validator being updated. So if you are programming on Solana, you can treat this account differently. Like you don't need to really care about this account. Like you just need to know if you want to deploy your program, you need to use BPF loader, and if you are transferring SOL or you want to reallocate the memory inside your account, you need to use system program. Yep. And all this account is owned by native loader program. I got one question to you guys. Does anyone know who's the owner of the native loader program? Want to guess it? Who's the owner of the, like we can saw that the owner of your wallet is system program. But who's the owner of the native loader program? No idea? Okay, actually the owner of the native loader program is system program. Like this is like they need to have a final loop so that every account have an owner. So it will end up to be the native loader program's owner is system program. So it will become a loop. So you can guarantee that every account have an owner as a program. Okay, and when it comes to programming on Solana, say you want to create your own smart contract, we call it program on Solana. And also, the program's owner is BPF loader. So that's if you write your program, you need to deploy it to the network. After that, the program's executable field will be set to true. So that during the execution time, the validator knows that, oh, this is a program, so that this is a read-only. That means that if there are like people minting different like NFT or like mint coins out, they all can be executed in parallel because this program are read-only, so that the memory won't change. So there won't be a write lock right there. So we will say the program itself is stateless. And here comes to where we store the data or where we store the state inside Solana. We use a program-derived address. If you have programming on Solana, you might heard of this. This is a special approach to store data. So that's there's a limit right there. There's a 10 MB limit. So if you write more than this, you need to like switch to another account. You're not allowed to like store all this data within one account. And what's special of the program-derived address? You can saw that it's owned by your own program, which means that this account can only be modified by the program you deployed it. And how does this been achieved? Actually, the program-derived address is not on elliptic curve, so that it don't have corresponding private key. How it constructed is it use seeds and the program to calculate the program-derived address. So it can bump the address out of the curve. And on the execution time, if we want, like, we have some token account, it's owned by the program-derived address. We want to sign it so that they are able to transfer the token between different accounts. We need to like specify this inside the program. So only the program have the access toward the program-derived, to the PDA. Yep. And here's the, like, most PDA people are using these days is that your token account itself is a PDA. So how we calculate a token account is that we use the wallet as the seed, one of the seeds, and then the token program, and also the token mint you are using. And the program, and there's a associated token program. This way is to like defining. If you don't know others, I would say this is a deterministic way to calculate others' account, so that you can even others don't have a token program right there, you still can create the token program for a token account for them. Yeah, I know it's a bit tough. This topic is really hard to understand right here, but yeah, at least you can follow the life cycle of the transaction to understand how your transaction being executed throughout the program and throughout the validators. And this is what we have covered today. And if you are interested in the more detail of this program, you can go to Solana howitworks.xyz to see the some uncovered part inside this presentation. Also, if you are interested to become a builder, we have you can go to the website and scan the QR code right here and see what program you are like to join with. And also, we have a dev shop, so we are able to like help you accelerate your program. So thank you for your listening, and enjoy hacking. By the way, anyone got a question after this presentation? I know that it's a bit tough. Like, curious about how the transaction like been included inside the block. Yeah, I'm not pretty sure I explained it well. Okay.
Why, I know Solana is fast.
Yep.
Why sometimes when I transact with smart contract, it's not that fast?
You mean?
Sometimes it's fast, sometimes it's slow.
Okay, so it's a good question. Like, there are a lot of issues. Sometimes that the network is congested. So basically, if you send out a transaction, it failed. It might be that maybe your RPC provider is not stable, so that it fails to like send out your transaction to the validator. Or sometimes it come out to be your priority fee. I didn't cover it. It didn't cover this part inside this presentation. Like there's a priority fee settings inside the network. So if like people are minting Mintcoin right now, and the priority fee is not high enough, if you are like say minting the same Mintcoin, the priority fee is not high enough. Like you still need to compete with each other, so that the validator might not accept your transaction in it, since they have a given time they need to produce their block. So if at that given time your transaction didn't been included inside the block, maybe your transaction will be dropped. Or sometimes happens is that even the transaction included inside the block, but it didn't like get finalized due to like the uptime of the validator. So the transaction be dropped during the runtime level. Yeah. I mean, if you like keep retrying the transaction, it will like eventually be included inside the block. And the way you say that it fails, there are two kinds of fails. One kind of fail is that your transaction been included on the blockchain, but the logic failed. But actually, the transaction status is, yeah, it's success to be included on chain, but the logic itself failed. That case will be treated as this transaction is success, but the logic failed. And I'm assuming that you're asking about the transaction didn't be included on chain. Is that the case? Not pretty sure. Yeah, if that's the case, I think maybe you can switch to like different RPC provider, or maybe you can set the priority fee a bit higher during the congesting time. Yeah. Yep. Okay. Any questions right there? No? Okay. Okay, I'll be right at the stage. So if you still have a question, feel free to come reach out to me.